Hello guys, welcome back to Maths on African Motives. Still on A-level pure mathematics. We are going to be focusing on the modulus of a function in this platform. This is one of the important parts. Remember last time we referred to the inequalities, and I also referred that there is a part that we can solve whereby you'll be given the modulus of a function. We used the first method where we saw that we could have solved inequalities by squaring both sides. Now we shall see, in fact, in another class, maybe if possible, but for now, what I want us to know is the relationship. All right, so we have got the relationship in this case between a function and its modulus. Okay, so we've got the relationship between a function, all right, that is the graphs which represents the function. Okay, so we've got the graph of y is equivalent to f of x, which is your normal function, and its modulus, which is y, is equal to the modulus of f of x, like this. Okay, what does it actually mean if you are referring to the modulus of a function? Let's say we have got a function in this case, which is given, let's say we are given y, which is equivalent to f of x. And this y, which is equivalent to f of x, can be represented as, let me just have a sketch. This is just a sketch, guys. Okay, so this is our y, which is equal to f of x. All right, let's see. Okay, something like this. Remember, that's your x-axis, your y-axis here, and we've got a 0 here. Okay, so let's say our function of y is equal to f of x is like this. It passes through the points in the x-axis here. Let's say this is A and this is B. So this is your function, okay? That's y is equal to f of x. Therefore, the modulus now of this function, okay? Therefore, the modulus, okay, of y is equal to f of x, which is its modulus. What you're going to do is that you are going to reflect the part that is below the x-axis. Okay, we've got our x-axis, so we've got above the x-axis, then below the x-axis. So you are going to reflect this part up below the x-axis, this part that we see here below the x-axis. We reflect it, so we're going to see this part above the x-axis. Let me just show you what it's going to look like. We're going to have it above the x-axis like this. So which means if this point in the y-axis was, let's say, negative c like this, let's say this is your, remember, from your quadratic function, f of x is given as ax squared plus bx plus c. So for us to have this point, it's a negative, okay? This point is going to be reflected, and we see it in the y-axis at this point. So this will be your point C. So what I'm trying to say is that your graph is going to be like this graph, okay? It's going to be like this. That is what you're going to have. We've got our x-axis, our y-axis here, the point 0. So it is going to be at the point A, okay? This was our point A. Then it goes above like this. So that is what you're going to have in this case. Then it goes back like the way that it was previously, like that. All right, whereby that's our point A here, our point B, and our point C, like what we had from this part. So as you can see, if you are dealing with a modulus of a function, you are simply taking the part that is below the x-axis, then it's above. We are not working with negative values. We are only working with the positive values, okay? So remember that the modulus simply means plus or minus. So whatever answer with a minus, it is going to be multiplied with a minus, so it becomes a positive. That is why you see all the part is a positive. All right, let me indicate something here. Let's say we've got our y, which is equal to f of x, and this f of x that we are referring to is a straight line where we know that it's written as f mx plus c. All right, if this is a straight line, let's say we have sketched our graph. In this case, we obtained something of this nature. let's say you managed to have or your graph, to sketch your graph or to draw your graph like this. All right, this is what you're going to have as the original function. Let's say our original function was like this. All right, let's say this was our straight line passing through the point. Let's say this is A and this point is C, which is in the negative. So let's just say it's a negative C. Okay, or we can just even put the numbers here. Let's just write our numbers. Let's just say this point is 3 and this point maybe it's -1, whatever point that you can think of. Okay, this is your f of x. If now we are dealing with its modulus, which is the modulus of f of x, which is the modulus of the straight line that you are given as we are given here, which is mx plus c, whatever straight line that you're going to have. Okay, so in this case, I'm taking from this function that we're having. So remember what we said, as long it's below the x-axis, this is the x-axis here, and this is the part that is below the x-axis. So we are going to reflect this part, okay? We take this part above the x-axis. So what does it mean? We are simply multiplying each point by a negative. We are simply multiplying each point by a negative. So if this point was -1 in the y-axis, if we multiply this point by a negative, it is going to be a +1. So we are going to see that we are going to have a point at 1 in the y-axis. So that is what the graph now is going to look like. Okay, so in actual sense, if I am going to draw this graph properly, it was supposed to be like this. For the modulus, we are supposed to have something like this. All right, remember, this was our 0 here. So it is going to be like this. Okay, at 0.3, then it goes up like that. Okay, so remember, this is 1 and this point is 3. So this is now the modulus of the function, where we can write this as y is equal to the modulus of what? F of x. Okay, this was your f of x. This normal straight line, this was your f of x. But now we are representing the modulus, taking that part which was in the negative. Remember, there was a part which was in the negative here, which was passing through -1. You now write it above. That's how you represent a modulus. So guys, it's pretty clear and pretty easy like that. Okay, so I'm just going to quickly give you some examples whereby we are going to sketch, okay, whereby we're just going to sketch certain functions. Actually, the modulus of a function, that's what I'm going to be focusing with in this case. Okay, let's say in this case, we are given the modulus of, so it's just sketch. In this case, I just want to sketch. Okay, so we're going to sketch the modulus, or y is equal to the modulus of x plus 2 like this. Okay, so how do you sketch this? Okay, if you do not know this part, guys, this is what you take. If you know the actual graph of y is equal to x plus 2, then it's going to be easier, because for this graph, what you simply need is to know the x-intercept and the y-intercept. Okay, so we know that we need the x-intercept where we know that y is equal to 0. Okay, so for the x-intercept, if y is equal to 0, we are going to have 0 is equal to x plus 2. So that means if you transpose to the left-hand side, it's going to be -2 is equal to -2 is equal to x. So that means in the y-intercept, x is equal to -2. Okay, then for the y-intercept, we know that x is equal to 0. Okay, so if x is equal to 0 here, your equation is going to be y is equal to 0 plus 2, where y is equal to 2. Okay, I'm referring to the original function of y is equal to x plus 2. Therefore, we can have our modulus from there. Okay, so this is how your graph was going to actually look like. So guys, just pardon me on sketching here. You know, if you're dealing with electronic devices, you do not represent exactly what you want to represent. Okay, anyways, that's what we're going to have as our Cartesian plane. Our x is at -2 and y is at 2. So this is, let's just say this is our -2 here, and this is our y, which is at 2. Okay, the graph was supposed to be like this, or the line was supposed to be like this, passing through -2 and 2. This is the graph of y is equal to f of x, which is x plus what? X plus 2. Okay, but the modulus, guys, of the graph, I want you to take note. There is a part which is in the negative region here. This is part that is going to be in the negative region from -2 going down here. It's in the negative. You are going to reflect this above the x-axis. So you're going to see this graph above in this manner. That is going to be the modulus of the whole function. Okay, so that means the modulus, we are going to end up with something of this nature. All right, so this is going to be like this at -2. So we no longer have this part below because we are dealing with positive values only. So this becomes the modulus now, where we can write as the modulus of x plus 2. All right. So I think with this information, we understand basically what is referred to as the modulus of a function. All right. So the second part that follows now is on a condition that you are actually solving equations. Okay, guys, take note. You might be solving basic equations. You are using these graphs now to solve equations such as maybe, remember, the question can be solved graphically or you are just solving the normal way. Okay, so let's say we are given a question to solve, okay? Solve for x, all right? We are solving for x, whereby we are given the modulus of x minus 2, all right? This is x minus 2 like this, is equal to 2x plus 1. Okay, take note, we could have solved this equation by squaring both sides. Remember, we are given, if you're given a modulus, you can square the equation, then you solve. But we can solve this graphically by sketching the two graphs. That is the graph of y is equal to the modulus of x minus 2, and the graph of y is equal to 2x plus 1. But sketching this on the same Cartesian plane. So we're going to sketch this on the same Cartesian plane or on the same axis. All right. So how are we going to do this, guys? Let's start with the modulus. Okay, we are given y is equal to the modulus of x minus 2. So remember what I said, what you simply need is to know how to draw or to have the graph of y is equal to x minus 2. Okay, by just knowing this graph, then it's going to be easier for you now to draw or to have the modulus, where we just need our x-intercept, where y is equal to 0. So if y is a 0 here, that means 0 is equal to x minus 2. So you can solve for x by transposing 2 to the other side. So x becomes a 2. Then for the y-intercept, we know that x is equal to 0. So if x is equal to 0, y is going to be, substitute a 0 in place of x. That's 0 minus 2. All right, sorry for that. So this is going to be 0 minus 2. That's y becomes minus 2. All right. So our graph in actual sense was supposed to be of this nature. All right, I'm going to show you how it was supposed to be like, guys. Okay, so we have got our y-axis and x-axis, right? So sometimes, okay, sometimes, guys, you know, to sketch, I talked about this before. So this is your x-axis, that's your y-axis, and we can just indicate here as 0 here. All right, so the points at x is equal to 2, that's when y is equal to 0. So we just see, we can just say it's at this point, and y is equal to minus 2. Y is equal to minus 2 at this point. All right. So in actual sense, if the graph was supposed to be like this, guys, please take note what the graph was supposed to be like. We're supposed to have our graph of this nature passing through 2 and so on and so on. Okay. But this is the modulus where I told you that you are no longer going to work with the negative part of the graph. We are going to work with the positive only. So that means this part in the negative, we're going to write it above. And if you are to reflect this, you're going to see that this negative 2, if you multiply the negative 2 by a negative, it is going to be a positive 2. So you're going to see our graph now passing at positive 2. So that's how our graph is going to be like. So it's going to be above the x-axis like this. Okay, so we no longer need this part that is below the x-axis. It's just to assist you to have the actual graph. Okay, so that's what our graph was going to be like. This is the modulus. Okay, so we're given the modulus in this case. And from our modulus, so you can just write our equation here. That's y is equal to the modulus of x minus 2. All right, so take note for this modulus, this part here, what it means, guys, it means this line from this point to this point that I'm indicating. This is the graph of y is equal to x minus 2, which is a positive. From this point of minus 2 here up to, we don't know, up to infinity. Okay, this point we didn't indicate. Okay, remember we said this is a 2 here. From this point to up to these 2 and going on and then so forth. This is just representing the graph of y is equal to, remember modulus, we said it's plus or minus. So this one is for plus and this one is for minus. That's why we multiplied this by a negative. So it's like y is equal to minus x minus 2 like this. That's what the modulus simply mean. Okay, so I'm just going to leave it. It's going to help us, especially if you are solving equations, so that you understand what each line represents. All right, so we have the modulus graph. Then we move on to the line of y is equal to 2x plus 1. Remember, we are still sketching on the same graph. So from this point, we know that our x-intercept, we need our x-intercept where y is equal to 0 here. If y is equal to 0, that means 2x plus 1. 0 is equal to 2x plus 1. Negative 1 is equal to 2x. If we transpose, divide by 2, we are going to have negative 1 over 2. All right, then for the y-intercept, it's at a condition where x is equal to 0. So y is equal to, if x is equal to 0 here, that's y is equal to 1. Okay, so we've got the point at negative 1 over 2. And at point y, which is equal to 1. All right, so we are going to have our graph like this, guys, okay? So our graph is going to be like this. At x here, we are going to have x, which is a negative half. So let's just say this is where we've got our negative half, and y, which is equal to 1. Let's say this is our y, which is equal to 1. Then you join the points. This one, we are not given a modulus, so you simply have to join the points. All right, so that's how your graph is going to look like. So in this case, we do not know, is it going to reach this point or not? Are they going to intersect at this point or not? For now, we do not know, but that's how your graph is going to be like. Okay, so when we are given that to solve this equation, guys, it simply means that, okay, I want you to be very, very clear. Like I said, at this point, we do not know, is it going to intersect or not? Okay, but if it is that they are going to intersect at this point, because this one is a definite point, yes, they are going to intersect at this point, that one is a definite point. Okay, so now for you to solve this equation, we need the point of intersection of the two graphs. At this point, there is supposed to be a certain solution where we do not know, but that's the value of x. So let's just say that's our x1. Then at this point, we shall have another value of x, which is going to be our x2. Okay, but remember, it's a sketch. If it was on a graph, then you are simply taking the values as they are, because the graph, on the graph, you can tell. But this is a sketch, guys. So how now are we going to solve? Because the question is for you, maybe we are given to sketch, then after that, solve. This is what you're going to do. The first part is an intersection, okay? So our solutions now is going to be like this. The first part is an intersection of the line, okay? We did write the equation, but the equation of this line is y is equal to 2x plus 1. Okay, so let's write the equation. That's y is equal to 2x plus 1, this line. Y is equal to 2x plus 1. Okay, so the first point, which is our x1, is an intersection of y is equal to 2x plus 1. And that part of the modulus, which is now carrying a negative here, which is y is equal to negative x minus 2. That is now the first point. Is the intersection of these two graphs. Y is equal to minus from that modulus. Remember, I told you One is going to carry a positive, this one, and the other one, it carries a negative. So from these two, we can solve for the value of x because we know that at the point of intersection, these two are equal. The values of y are equal. So therefore, it means 2x plus 1 must be equal to negative x minus 2. Okay, so we can expand the brackets by negative, which is going to be negative x, negative and negative, that's plus 2. So you can transpose negative x to the right-hand side is going to be 2x plus x. That's 3x is equal to 2 minus 1, which is 1, divide by 3 by 3. So that's our x is going to be 1 over 3. All right, so our x here is going to be 1 over 3. So if our x is 1 over 3, but we need the point, actually, well, okay, we can just leave it like that because we are not about we are not asked about the point of intersection. Yes, it's just to solve for x. Okay, so that means at this point, our x is 1 over 3. That is what we have in this case. Okay. If our x is 1 over 3 at this point, what about at this point, which is the intersection at another point? But what is the intersection of this? This now is the intersection. So now we have got the intersection of that same line, which is y is equal to, that's y is equal to 2x plus 1, this line, okay? The line of y is equal to 2x plus 1. And the modulus function, but this time of a positive, which is y is equal to x plus 2. As you can see, it is a positive gradient. That's why we took it like that. So we've got y, which is x minus 2. So now we have to solve for these to find again another value for x. So since y and y are equal, it means these two are also equal. So 2x plus 1 must be equal to x minus 2. So you can solve transpose here. So x is going to be, this one is going to be a negative, okay? So you're going to be 2x minus x is equal to, that's minus 2 minus 1. Okay, 2x minus x, that's x is equal to minus 2, and it does not make sense with where our graph is at this point. So it means at this point, this is not going to intersect at this point, but it was going to intersect if we were to proceed at the other point. Remember what I told you guys, that we took the other part here. Remember, it was supposed to go that way. So that's where maybe it was going to reach, not at this point. So it simply shows that this graph was not going to meet at this point. So it was not going to meet at this point. That's what it simply means. These two graphs were not going to meet because we are having our x being a negative 3 here. It simply means it's not actually exactly what it's supposed to be like. So it means that's not a point of intersection. Your graph was just going to intersect at one point in this region. Okay, that is the region of the modulus, not this other side. We are not considered about that other side. Remember, from our graphs that we are given. So that's how you actually work to solve such typical questions. So in this case, according to the graphical part, we are limited at this point. At the point of minus 3, we are limited from our graph. Okay, so that's how you sketch the graph and how you determine the solution from this graph. Okay, so I hope we understand this part, guys, and it's very clear. The other part now, it will be when you are solving inequalities. Okay, so for the solving part, I think, guys, this is clear. Okay, this is pretty clear. If you have questions, I think we can share in the comment section, and we are going to be revising question papers also. So as we will be revising question papers there, we can have some questions. Okay, so now we want to use the same modulus of a function, but to solve inequalities. Okay, to solve inequalities. Remember, we had the part of what? Of inequalities, where you'll be given something of this nature. If I am going to win, I'm just going to try, okay, to indicate this one. The question will be solved. Let's say we are given 4 modulus of x is less than the modulus of x plus 2, like this. Okay, We worked with this typical question before, and I told you that if you are given this type, you can square both sides, then you solve your inequality, all right? Because we've got the modulus on both sides. But now we want to use the modulus of a function. We want to work with this from the sketching of the graphs that we have. Okay, so this is what you're going to do. Definitely we've got two functions here, okay? So we are going to sketch these two functions. I'm going to explain what does this inequality sign mean from the graph if you have drawn the graph. Okay, so the first one is for y is equal to 4, the modulus of x. So we've got 4 modulus of x. So it simply means we were supposed to draw the graph of y is equal to 4x. Okay, y is equal to 4x. And we know that for the graph of y is equal to 4x, guys, we've got something, we've got a positive gradient. So we know that our graph was supposed to be like this. This sketching of graphs, guys, is taken from your O-level mathematics there. You must have a certain idea of how to draw this graph. Okay, so that's what you're going to have in this case. For this one, we know that when x is equal to 0, y is equal to 0 because we do not have a constant here. So it is going to pass at 0 here, and it has a positive gradient. So you can just sketch something like this. It has a positive gradient. So it was supposed to look like this, passing through 0 like this. This was supposed to be the line of y is equal to 4x. But this is the modulus. We no longer work with the negative region. So we are going to take down or to remove the negative region. Then we write it as a reflection in the other part of the region like this. All right. So we are going to have it at this point. All right. So that's y, which is equivalent to 4, the modulus of x. So like I said, it simply means it's a combination of two graphs. The one with a positive gradient, which is of y is equal to 4x, and the one with the negative gradient, which is of y is equal to minus 4x. That's what it means. So you just need to know, there's no need for you to write this on the graph. You need to know what it means actually. All right. So that was for the first one. Then we move on to the other one of y is equivalent. So the first question would be for you to sketch, then you use your graphs. It will be the question will be yes or otherwise. So if it is yes, they mean use from the graph. Otherwise, then you can square whatever that you know there. All right. So the other graph is y is equal to the modulus of x plus 2. I think we sketched this graph before. Let me check because we can be repeating these graphs now and again, or at least we have this. All right. Okay, it was x minus 2, not x plus 2. Okay, that was x minus 2. Okay, so I thought we had this one. So we're just going to redo this graph. Okay, sorry for that. Sorry for that. Okay, so our graphs are here. All right, this is where we have y is equal to the modulus of 2x. So we just know from the line of y is equal to x plus 2. If x is equal to 0 here, if our x is equal to 0, that means y is equal to 2. So this graph was going to pass at y is equal to 2. So that's y is equal to 2, maybe somewhere here. Then if y is equal to 0, we can substitute y is equal to 0. That means x was going to be minus 2. I think this one we are used to it, guys. So we're going to have our x at minus 2, maybe somewhere here. Okay. So from the normal sense of the graph, our graph was going to be like this. From the normal sense, we're going to have our graph drawn from minus 2 up to 2, then up to like this. I don't know if they were going to meet at a certain point or not. That is what our graph was going to be like, also going in the negative region. But I told you this is a modulus, so we do not need any negative. So the negative part is going to be drawn above. So it is going to be like this, above. So that's where we are going to have the modulus part, all right, which is the negative one. All right, so it simply means we have got two graphs here. Okay, we have got the graph of y, which is equal to the modulus of x plus 2, which I saw, this one is got a positive gradient. So it's like we've got the line of y is equal to x plus 2. And on the other side, we have got the graph of y is equal to minus x plus 2. It simply carries a negative. That's what it means actually. So this is a negative and that one is a positive. Okay, so the question was for us to solve a condition where the modulus for my modulus of x is less than. Okay, If a function is less than another function, it simply means you take values of x where this function is below, okay? Where this function is below this function, it's less than. So you take where it is below the function, okay? This is the line, okay? I want you to take note, the line that we have here, which is in white. This is our modulus, okay, of the 4 modulus of x. Where do we have this line below the graph of y is equal to, okay, y is equal to the modulus of x plus 2. Where do we have this below, okay? So we are going to check here. From our line of y is equal to the modulus of x, which is this one. From this point up to this point here, it's above this line. So we can't have any, we're not going to have any solution from this side because it's above. We need where it is what? Below. Okay, if you move on from this point here, okay, if we go from this point here, we go down. At this point, we are moving. We can see that up to this point, our graph is below from this point, okay, up to this point here. We can see that the graph of y is equal to 4 modulus of x. It's below this graph of y is equal to the modulus of 2x. It's below. So which means our solutions are going to be taken from this point. Let's say this is A up to this point. Let's say this is B. So in between this region, this graph of 4 modulus of x, it's below the other graph. Okay. If you move on from this point now, let's check. If we move on from this point as we go here, we can see that it's now above, it's on top of this graph. So there is no solution that we can have from this side. So our solution from the graphical method is going to be taken in between these points, which is A and B. So where are we going to have our A and B? We know that in between this solution, the inequality is supposed to be x, it's greater than A, but less than B. It's in between A and B. Take note, if it was from this graph like this, okay? Sorry for that. If it was like this, let's say here it was written as less than or equal to. It means also your answer in this case is going to carry the equal to on this final answer. You're going to have equal to and equal to. But we do not have that equal to, so your answer is just going to be with less than like that. Okay, so this is the presentation of how your answer is supposed to be if it is in between two values like this. Okay, so how are we going to have the value of A and the value of B? This is what you're going to do. We talked about this when we were solving a normal equation. So these A and B are actually the critical values. These are critical values. I talked about critical values if we're solving inequalities in our first class. All right, so we are going to take this as the critical values, which means we must solve for x. And remember, if you are finding critical value, you are solving for x. So we are going to solve for x at this point, okay, which is a combination of two graphs. It's a graph of y is equal to the modulus of x plus 2, which is a positive, which is it's a combination of y is equal to x plus 2, and it's a point of intersection of y is equal to minus 4x from the modulus of that 4x that you talked about. Remember, I told you modulus is plus or minus. So the one in this side, it carries a negative. Okay, that's a negative gradient. So we talked about this. We said at the point of intersection, these two are equal. So what am I going to do? I'm just going to solve 2x plus 2 is equal to minus 4x. So x plus 2 must be equivalent to negative 4x. So for x, that's x. Minus 4x to this side is going to be a plus, and then 2 to this side is going to be a negative. So x plus 4, that will be 5x. So we are going to obtain 5x is equal to minus 2. Divide by 5. So x is equal to minus 2 over 5. So our x in this case is going to be negative 2 over 5. So at this point here, our x is negative 2 over 5. Then we calculate the value of x. That is if they are going to meet at that point. Maybe they are not going to meet like what we saw previously. Let's see. All right. So on this part B, it's a combination of two graphs. It's a graph of the same modulus of x plus 2, which is the line of y is equal to x plus 2, and the modulus of 4 plus, which is a positive y is equal to 4x. So we're going to solve these two equations of y is equal to x plus 2 and y is equal to 4x with a positive. So these two are equal at the point of intersection. So that means x plus 2 is equivalent to 4x. So 2 is equivalent, we can transpose x to this side, which is going to be 4x minus x. So 2 is equivalent 4 minus 1, which is 3x, divide by 2 by 2. So x is going to be 3 over 2. All right, is that so, or is that so? Divide by 3, sorry, we must divide by 3 here because we want to solve for x. All right, sorry for that, sorry for that. Okay, so we're supposed to divide by 3 here, by 3 here to remove these 3. All right, so our x is going to be 2 over 3. So that's our x here at B is 2 over 3. So we've got a 2 over 3 there. But remember the presentation of the answer that I referred to. I said our answer is supposed to be x is greater than a, but less than b. So therefore, from this solution, our x is going to be greater than a, which is negative 2 over 5. So that's negative 2 over 5. And less than, our x is greater than negative 2 over 5. The same x is less than b, which is 2 over 3. All right, so that's it. We have got the value of x from this one. Okay, so that's how you simply solve or evaluate or solve the inequalities if we are dealing with sketching of graphs with the modulus of a function. So I think with this information, guys, we can be able to attempt questions on how to solve inequalities and just to sketch. Okay, so I'm just going to give you questions that you're going to try and work on. Revise as much questions as possible. If there's a question with a challenge, then let us know in the comment section so that we can work from that question again. Okay, so here I've got some of the questions that I want you to work on. So each and every question you sketch on the same diagram. Okay, sketch same diagram, sketch on the same axis. Okay, so the first one I want you to sketch. All right, sketch. Okay, so I'm not gonna, okay, let me just write. So it's sketch here. So I've got y, which is equivalent to the modulus of x, and y, which is equivalent to the modulus of 3x minus 2. So that's the first one. Then from the same question, I want you to solve this. Solve the equation. All right, solve the equation. The modulus of x is equal to the modulus of 3x minus 2, all right? Also, I want you to solve this one, yes, or otherwise, but in this case, I want us to use yes, but for the proof, you use the otherwise method, which means use that part that we talked about in inequalities, okay? So hence or otherwise, solve the modulus of x is, okay, this one is less than, so it's less than the modulus of 3x minus 2. So you just do the same way as what we did from that one, okay? So this is the first question. Then I'm just gonna give you the second one, then you try and work out as you can. Okay, so the second question, the others just revise as much question papers, guys, okay? So on the second one, so like I said, each and every graph you sketch on the same axis, okay? Y is equal to the modulus of x plus 2, all right? So we've got the modulus of x plus 2. Then, yes, all right, yes, find the set of values, okay? That is the set of values of x, right? Of x for which, all right, for which the modulus of x plus 2 is greater than 2x plus 1. Okay, so if you're given hence, therefore it means you must have also a sketch of the graph of y is equal to 2x plus 1. There is no modulus here. It's a normal line, okay? So I want you to try these two questions where we've got a challenge. Let us communicate, guys, on the comment section so that we can work on that question again together in our next class. So that's what we have, guys, for Maison African Motifs. Don't forget to share our videos to your friends and colleagues at school so that you also benefit as a family. Then let's invite as many learners as possible. Yes, let's invite others, guys. This information is very, very important, not for you only, but also for the others which are around you, guys, okay? So don't forget to share. If you're new, you can subscribe so that you become part and you can be part of the family, Maison African Motifs. And don't forget also to share, because you are new, share to your neighbor also, so that that neighbor can benefit also from this information that we have as a family of Maison African Motifs. Till we meet again.